So for the last set of problems, there's a set of instructions. And the first set of instructions says, make sure the equation is in standard form and use that to identify the y-intercept of the parabola. So this is definitely in standard form. It doesn't have any parentheses, so there's nothing to multiply out. There's no like terms to combine. So it is in standard form. And it's supposed to use that to identify the y-intercept. That's always the last term if it's arranged in descending order. So A, the y-intercept is 71. So the second, B, convert the standard form of the quadratic equation to vertex form by completing the square. Now, you can do the method of completing the square that's algebraic, but I'm going to go ahead and just use the model of algebra tiles for this one. And I find it easier to draw out on a graph paper. So I'm going to write y equals x squared plus 16x plus 71. And then I'm going to use the graph paper to model this, right? So I've got... we're going to say the 4 by 4 is an x squared, right? And now I need to break these. I need to kind of line them 8 here and 8 here to make a good square. So I'm going to just do them like this. So 1, 2, 3, 4, 5, 6, 7, 8. And then same down here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I've got this model. This is x squared plus 16x, right? And now I need to kind of fill in the rest of this. So first off, I've got 71. I'm having a feeling that this is not 71. Let me just kind of look and see how many this would be. This would be 1, 2, 3, 4, 5, 6, 7, 8 by 8, right? This is what's in here is an 8 by 8 square, right? An 8 by 8 square. So I need 64. There should be 64 of these in here, right? So 64 in there. But here's the thing, I have 71 tiles. I have 71. There's an extra here, 65, 66, 67, 68, 69, 70, and 71. So I have, here's my square, here's my completed square, but then I still have these leftover tiles. So now I can use this to write an algebraic model. I use the algebra to create this geometric model so I can picture it. Now I can use that to write back in algebra terms. This is x long and x long right here. This from here to here is 8 long and 8 long, right? So I just created an x plus 8 by x plus 8 square. Right? That's the same thing as saying x plus 8, right? X plus 8 times x plus 8. So I can write that pretty easily as x plus 8 squared, right? But the thing is I don't just have x plus 8 squared. I have this extra 2, 4, 6, 7 tiles. So I have this whole square plus 7 more tiles. So y equal to x squared plus 16x plus 71 is the same thing as y equal to x plus 8 squared plus 7. So this is standard form, this is vertex form. And I use my algebra tiles to help me move into vertex form. So over here for B, convert standard form to vertex form, y equals x plus 8 squared plus 7 more. Right? All right, so that was B. C, use the vertex form to identify the vertex of the parabola and the axis of symmetry. So C, the vertex is at negative 8, positive 7, right? Because you take the opposite of this and keep that. The axis of symmetry is just at negative 8 on the x-axis. Axis of symmetry. Remember, it just goes through at that x point. It's just an up and down line at negative 8. So if you write negative 8, that's pretty good. What you really should write is x equal negative 8 so that we know we're talking about going up and down. Okay, and then D, use the y-intercept, vertex, and axis of symmetry to create a sketch of the parabola. Choose a good scale to show the parabola, vertex, and y-intercept. So that they should be plotted accurately. So the thing is, I have enough information now that I can make a pretty good sketch. But notice that I have to plot the points -8, 7, but I also have to plot 71. So this is the tricky part, is choosing a good scale. I have to get all the way to 71. So I'm actually going to choose to go by tens. So this should be 10, 20, 30, 40, 50, and I'm going to write 50 right here so that I know that that's that scale. 10, 20, 30, 40, 50, right? And I technically don't need to go by the same scale on the X as the Y. If I wanted to go, and so maybe I won't, so that if I wanted to go by ones, I could. So maybe I won't, so that I can plot that 8 a little more accurately. So you don't have to choose the same scale. I want to get all the way up to 71, so I needed to choose to go by tens here. I don't need to choose to go by tens on the x-axis. So I'm just going to go by 1. 1, 2, 3, 4, 5 on the x-axis, right? So when you choose to make your x and your y different scales, you just need to be careful for how you count. So I'm going to plot 71 as my y-intercept. So that's going to be somewhere like right there, very close to the 70 mark, right? And then I'm going to plot -8, 7 for my vertex. So 1, 2, 3, 4, 5, 6, 7, 8. But then when I go up 7, I don't count up 7 because that would put me all the way up here at 70, right? I'm going to make my point right underneath the 10. So there's my vertex right there, right? So this is still getting me kind of off the graph, even this scale. So it might have been better to go by 2s down here so that I can stay on the graph. So I'm going to change that. We're gonna say that's 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So now I'll try again. Plot this vertex. -2, -4, -6, -8, and then up 7. But notice going up 7 just puts me right under the 10 mark, right? So here's my vertex. Here's half of my parabola, right? And then my axis of symmetry goes right down the middle, see, at this x equals -8 line. So the other half of the graph should look like this. So notice that this sketch is a little bit better and more accurate than these sketches that I made over here, where all I knew was the vertex, and then I was just kind of guessing how wide this was. I mean, this could be this wide for all we know, right? Because I didn't find another point to kind of guide me. But here on this, now that I know what my y-intercept is and my vertex, this helps me know exactly how wide it is. So this is a much more accurate sketch. Notice I have to do a couple things to make this accurate. I have to label my scale so that I know what I'm counting by. I had to choose a good scale, then label the scale so I knew what I was counting by. I had to accurately plot the vertex, accurately plot the y-intercept, and then I knew how wide it was going to be from here to here, and I used the idea of the symmetry to make it how wide it was over there. So you should be able to do the rest of these problems. Notice these are all in standard form, standard form, standard form, standard form, standard form, not in standard form. So notice on this last one you have an extra step where you need to get this in standard form first, move from factor to standard, then you can move on.